Hello guys, welcome back to Horus Labs YouTube channel, and in today's episode of the Becoming a Cairo Not series, we're going to be taking a look into understanding Cairo's ownership system. Now this is going to be an amazing episode. We're going to be covering a lot of things ranging from the concept of ownership to moving variables to understanding how the drop traits, the copy trait, the clone method with arrays, references, and snapshots, how these things work. So, if this is your first time joining us, I would advise you go back to check the previous episodes, right? So you'll be able to follow with this particular one. And without further ado, let's get started. Now, Cairo uses a linear type system, and this system is actually very important, right? Because it helps ensures that every piece of Cairo code, every variable, every value is used exactly once. This is actually very important for like a couple of reasons, right? One is it helps prevent runtime errors by basically preventing operations that should have caused those errors. For example, writing to memory twice. It helps with provability, right? As we saw in the previous episode, as for example, in the case of using dictionaries, the process of squashing when we call the destructs, right? This is something we're going to understand as we go further. And also, it also helps with abstracting the whole immutable memory of the Cairo VM right behind the scenes. And that's the reason why understanding ownership is key to being an amazing Cairo programmer. All right, so some things you're probably going to hear oftentimes as you probably move on, right, is this thing called moving and something called destruction. So when we talk about moving a value, right, we're basically just saying we're transferring that value from like the value attached to that variable, right, from one function to another function, right? So that's basically what moving is. And when we talk about destruction, we are usually talking about destruction in probably three senses. So one is when a variable goes out of scope, the other is when a struct is destructured, and the third is when you explicitly specify the destruct traits, which also again happens in the case of dictionaries. All right. So now, what exactly is ownership, right? So in Cairo, when we talk about ownership, we actually referring to variables, not values. So essentially, you do not how do I put it right? You do not exactly own values because essentially values are immutable. So that particular value is always going to remain the same, right? But the variable which points to that value can actually change. So the variable is what is mutable, and as such, it is what is owned by a particular code. So essentially, variables, when we talk about ownership, right, it basically means like a particular line of code in your program, right, owns that particular variable, and every single time the owner or that code, right, goes out of scope, that variable is essentially destroyed or dropped. So as we can see further when we go into like the variable scope section, a variable can be said to be within scope, right, when for example, when you're writing a simple Cairo program, we're going to be looking into this as we go into our code editor, right? So yeah, usually going to use this curly braces, right? So you open, this is the opening of your curly braces, and this is like the ending of your curly braces. So this variable s, which was instantiated here, right, is valid between this opening of the curly braces and this closing of the curly braces. So that is basically what we refer to as scope. So anytime someone talks about the scope of a variable, it basically means the period within that your particular program for which that particular variable is valid. So to properly understand the concept of scoping, right, we're going to dive into our VS Code, and we're probably going to set up a new folder for everything we're going to be doing into this episode. So as always, I'm probably just going to come to the README and update this BS6. So this is going to be understanding ownership. Okay. Now I'm going to come here and I'm going to make a new directory. Let me just call this, okay, let's rather just do a scab new and call this ownership. All right, so there's, yep, and we should have a new folder called ownership created. Let me close this. Yeah. So I'm just going to, as always, I'm going to rename this to BAC 6. Okay. And within BAC 6, right, we have the sleep.cairo, which has already been created for us. And since we are likely going to be touching on only ownership today, I'm just going to like clear everything and use the lib.char instead. Now we're discussing scoping, right? And we said the a scope a variable is valid for a particular scope, and most times a scope can be defined by the opening and the curly braces. So let's create our main function as always. The main function, and now I'm going to insert a simple variable. Let's say this variable is 0, and I'm going to do something. I'm going to, if this x now is equals to 0, what do I want to do? So I'm just simply going to create another new variable, and I'm going to say this should be 7, y should be 7, right? Now let's say something. All right, so let me say this main function should return a unit 8, and I come here to say, okay, it should return y. So when you look at this, you will notice it's throwing an error saying identifier. Let's say, so let's try, let's just, okay, let's just compile that. So I'm going to see it into BAC6. All right, and I'm going to, as always, just build. All right, so you can see it says identifier not found, right? And the question is, why is the identifier not found when we have the value here? Because, for example, if you try to return, let's say x, right? You can see x returns without any problem. But when we try to return y, we get that the identifier is not found. Now, that is because x is valid, x is still like within scope inside this particular function. And just like I explained earlier, right? So the scope of x is defined by this curly brace and this curly brace, right? So anything, in as much as you're trying to assess x within these two curly braces, and the value of x has not been moved or anything, right, you should be able to access it without any issues. But as you can see, the scope of y is essentially defined by this curly brace and this curly brace, and that's why when you try to access y from here, it tells you that y is not found because the compiler can't see y outside the scope. And that's just basically what scoping is. So, having understood scoping, the next thing we're going to be taking a look at, right, is the concept of moving. Alright, so just like I explained earlier, when we talk about moving, we're simply talking about moving a value, right, from the previous variable that was holding it like into another function. Now, most times when this thing happens, behind the scene, what happens is basically the variable which was holding that value initially, right, it gets destroyed within that scope, and a new variable is created to hold the same value. Now, one of the data types we can actually use to like effectively demonstrate this is the array data type. So let's just hop into our code editor and play around with arrays and just understand the concept of moving better. Okay, so I'm going to let me clear my terminal, and I'm going to clear this too. All right, so we're going to create let's once again our main function, right? And I'm going to create an array, a simple array. So let's call this, let's just use the shorthand array. Let's create an array, simple array, should contain 1 2 3. All right, now I'm going to create another function. So let me call this function append value, right? And this function is going to take in an array of type, let's say int 8, and it's just what it's going to just simply do is add a new value. So we're going to say we want to get the array and we want to add a new value to it. So in this case, let me add 21. All right, add 21 to it. Now I'm going to try to call this append value in our main function. So when I call append value, I want to pass in this our array. So when I do this the first time, I have no issues, but this array is moved into this function. This is how you're going to know. So if I try to, let's say, do something else with the array, let's say, for example, call the append value again with that same array, now you're going to notice we have an error. So the compiler is kind of like shouting at us. So if you overwrite, you see this error. It says variable was previously moved. So variable is previously moved. Now this error happens, right? Because remember we called the append value initially. So what happens basically is when we call this function, we move this value of this array right into this function. Now this function has ownership of like this array value, and as such you can't pass it or use this array anymore beyond like this function, right? So it's no longer available for use, and that's why you can't really pass it into this function. All right, so the next thing we're going to be looking at, let's just hop into our Cairo book. We just explained this, right? Is the copy trait. So we talked about the concept of moving and how this can affect like a lot of existing data types in Cairo, right? But now there's the copy trait, which basically helps to ensure that okay, these things do not happen, that you can basically like pass functions or pass the most basic data types right into another function without losing ownership of that function. Now the copy traits, basically how it works, right, is it simply just duplicates the fields right without allocating new memory segments, and it's basically already what's it called, it's implemented for like most basic data types in Cairo, field 256 and the unsigned integers and so on and so forth. Most of the basic data types we looked at, I think that should have been in chapter 3 or chapter 2, right? But it's not implemented on arrays and fields 252 dict. So on dictionaries and array you can't use the copy traits, and as such if you want to like let's say copy an array, right, there's a method called cloning we're going to look at later, but for right now what you just need to know, right, is like the copy trait is not really implemented for arrays and dictionaries. So but you can use the copy trait for other data types like structs and so on and so forth. So let's just dive back into our code editor and see how we can basically like use the copy traits. All right, so I'm going to just go back in, and we are going to, okay, let's clear this once again, and I'm going to create a basic struct. So let's call this struct point. All right, and this struct is basically going to have two values. So a unit 128 x and another unit 128. All right, so now we want to create a function, our main function, and this main function of course is going to like initialize or use the struct. So let's say p1 is going to be equal to our point struct, and we're probably going to say we want x to be, let's say, 23, and we want y to be 21, right? And so that's p1 essentially. Okay, we have an error. Unused variable, consider variable not jumped. Oh, ignore that. So now you can see we're having an error here which says the variable is not jumped. So we're going to look into the drop traits later. So for now you can just ignore it. But something we're going to do to remedy that, right, is we're going to be doing two things. Now, okay, before we do that, I want to show us something. Okay, let's just remedy that. I don't like seeing errors. So we're going to let's just derive the drop trait. So I'm going to explain what this does later. Sorry, it's supposed to be an ash. All right, I'm going to explain what this does later, right? But you can see it's like kind of like kills that error we had earlier. All right, so but to basically understand how the copy trait works, right? So I'm going to do something. So let's create another function, and this function is going to utilize our struct point. So it's going to need to take in a point, right? And we're going to probably do something or whatever we want to do with it, right? And both of them are into 128. So okay, let me just return into 128. Let's just perform a simple operation using it, and I just basically want to, okay, let's say we basically want to get p.x and probably add that to p.y, and so whatever value we get from that is going to be returned, right? So now let's try to do this. So if we try to call this function similar to what we did with arrays, right? If we try to call this function once, passing in the the P1 value, we're not going to get any errors. We're good, right? But if we try to call this again, passing in this, right, you're going to see we have that error now that said the variable was previously moved. So just like what happened with arrays earlier, we called this function foo with the p1 value, and when we called this, the p1 value was basically moved to like this function. So now trying to call it the second time throws the error that the variable was previously moved, so it's no longer like it's no longer available for use. So how we can do this, how we can remedy that, right, is implementing the copy trait. So when you implement the copy trait, you're basically like duplicating like this particular data type, right, or this particular variable we just created. So it means we can pass this in as much as we like. So we can pass it in multiple times as much as we like, right, because this particular data type, this particular variable, right, implements the copy trait. So you can use the copy trait for like I said, basic data types, all basic data types apart from arrays and what's it called, dictionaries. All right, so that's as much as you need to know about the copy trait. Now the next thing we're going to be looking at is the destruct trait. So for that, let's just hop back into our Cairo book. All right, so back in the career book, right, and scrolling to this section where we talk about, we look at the process of destroying values, right? So when we talk about destroying, right, destruction and stuff like this, so we're essentially just saying to the compiler, right, that we want to ensure that linear types are basically dropped each time, like they are out of scope. Now, this is actually super useful, for example, in the case of, let's say, dictionaries, right, where you need like to ensure that dictionaries are squashed for like provability, right? We looked at this in like the previous chapter. Now, when it comes to destruction of values in Cairo, we have like two types. So we have this called this type called the no operation destruction, which is essentially the drop trait, which we just looked at earlier. Then we have the second, which is basically destruction with the side effects, which is like the destruct trait. Now, the basic difference between the both, right, is that the drop trait, it doesn't really perform any operation. It doesn't like there's no computation. All it just does is it hints the compiler that okay, this value is going out of scope and I want you to drop it immediately. It's out of scope, right? That's all that the drop trait does. While for the destruct trait, most times this is most times, like I said, often used with dictionaries, right, where you want to perform a particular operation. So when you specifically implement the destruct trait, for example, in the case of dictionaries, we're saying okay, we want this this value, this dictionary, to be destroyed, and in the sense, like for example, the operation which is performed with like dictionaries, right, is the squashing operation. So we want this dictionary to be destroyed and its value squashed, right, to ensure that we can generate proper proofs out of it. Now let's hop into the career book and probably look at how you probably want to like use, sorry, hop into our VS Code and look at how you want to use like the drop traits. All right, so back in our VS Code, I think we already even did this, right? So for example, you noticed when we had the drop traits missing, we had this error that says the variable is not dropped. Now this is a problem with should I say data types, custom data types like structs, right? So you need to explicitly like hint the compiler, okay, here's the drop trait, and all I want you to do, right, is every time this what's it called, this struct goes out of scope, right? So for example, here it goes out of scope. I want you to ensure that the value of the struct is basically dropped. The same happens with the destruct. So with destruct, most times you probably want to like you probably want to like derive it, but like I said, in this case you probably want to do it on a dictionary, but just the same thing basically. So you derive the destruct trait and it tells the compiler, okay, when we're out of scope, I need to destroy this variable, and of course, like I said, it performs a certain operation. It might be squashing or any other operation, right? So but that's just about it as regards like the drop and destruct traits. All right, so back again into the Cairo book, let's look at the other things. All right, so the next thing we're going to be looking at, right, is the copy array data with clone. So initially I mentioned that the copy trait is not, you can't implement it for like arrays, right, for complex data types like arrays and dictionaries. Now it doesn't really mean that if for some reasons you want to copy the data of your array, you can't really do that. So you can actually do that using like the clone method. So if you're new to methods, I guess if you're like an existing programmer, you've probably heard about methods, right, in other programming languages. But if you're new, we're going to be covering it like I think in the next chapter, like in the next episode of the series, right? So let's just head back into VS Code and try to like use the clone method. Okay, so back in our VS Code, let me see. We had I think I made a bit of mistake out that I should have used like use different files so we could have like most of all this, but nevertheless I'm still going to try to ensure that when I push the VS Code you'd have most of these available. All right, so let's try to use the array method. So within our function, all right, let me just do it within this function, right? I'm just going to use a comment to separate it. So let's say using the clone method. Okay, so I'm going to create an array. Let's call this array, let's call this array1. You know what I'm calling it array1 later, so let's just use this. Okay, and that's 1 2 3 4. Okay, now we're going to clone the value of that array right into a new array. So we're going to say let array2 equals array1 dot clone. All right, so you've noticed something unlike most of the things we've looked at, right? When you perform a clone operation on an array, right, it creates new memory cells. It creates a new variable which holds like those the value of the new clone, right? So essentially if we try to print out array1, so let's try. So if we try to let's say print out, in this case let's say first array, I will try to print out array1, and what's the problem? Or 0 unused arguments. That's weird. Oh, sorry, forgot something. Yeah. Now treat. Oh, right. So you can't exactly print out array1. So let's just try to print out an element in array1. All right. So now we try to print out a single value works, and we try to do the same right for the second array. Let's call second array. Probably try to print out the first argument for the second array. You see, like it's kind of like the same thing. So essentially, we just cloned it. So it runs cap Cairo run. So essentially, they're going to print out the same values for the both arrays because all we just did was clone this array into this array. So essentially, when you perform this operation, you create new memory cells and you assign those you assign the value of those new array right to like a total new variable you create. So if we had the full function we had earlier, right, you can actually let's try to create it. So we had a function called append value, and that function took a reference to the array. So let's say this is a unit 8, right, and all it did was it got the array, then it appended an extra value to it. Okay, so now if we do this right, recall what we did earlier. Now we can actually do append value, and we're going to pass in array1, and we're going to do append value again, and this time we're going to pass in array2, and we're not going to have any issues. So as you can see, we cloned the array, and now we can actually pass it in again into the function. So that's how you can basically do something similar to the copy trait with arrays. All right, so let's head back into our Cairo to see if we are still missing any other thing. All right, so copy array data with clones. Now finally, return values and scope. We basically looked at all these, right? So essentially, when you call a function, so in this case you can see let a1 equals gives ownership. Now whatever is done within this gives ownership, right, is returned whatever value, right, is returned into A1. So A1 now has ownership of that value. In here we create a new value A2, which comes into scope. We pass it into this function called takes and gives back. Now this function takes in A2, now has ownership of A2, right, but takes and give back, yeah, and returns the sum A. So this value now gets passed into A3. So A3 has the value, the return value of takes and give back, and so that's just it. In here A3 goes out of scope, so it's just like a summary of everything we've looked at thus far. So just to summarize once again, right, scopes are defined by the curly brackets. When you talk about moving, you're basically moving a value from from wherever it is, right, into another function. You have the copy trait and the clone if you're trying to if you're looking to copy the values to ensure they are not moved. And we looked at the drop and the destruct. All right, so the next thing we're going to be looking at, right, is the concept of references on snapshots. So as you've seen thus far, right, when you trying to your program is going to be a bit difficult to manage if we have to always move in and move out and try to ensure we are actually managing states. So for example, in the case where you moved in array into calculate length, and array now has ownership of it, the only way to regain ownership of array back, right, into this main function is if you return it let's say as a tuple, for example. But all these things are just they're just plenty of necessary hard work. So but Cairo has something called references and snapshots, which helps simplify this process, and that's what we're going to be looking at in the next subchapter. All right, so in this subchapter we're going to be taking a look at references and snapshots. Now like we mentioned right towards the end of the last subchapter, the whole process of managing your program can get a lot complicated if you have to keep count or keep track of how ownership moves and manage the whole moving in and moving out of functions, right? So but to help remedy that, Cairo has this concept of references and snapshots that helps make your life easier. Now snapshots are very much interesting, right? So think of them as a snap or a picture of your variable or your data type at a certain point in time. So they are essentially like a picture, right? Like I said, taking of your value before any modification or anything happens. So if for example you take a snapshot of your variable at a particular point in time, that snapshot retains that particular variable or that value as it is, right, without reflecting any further modification you'd probably make to it. So I think one of the best ways to probably understand these things, right, is to try them out, play around with it, and see how it goes. So let's just dive into our VS Code, into our code editor, to play around with this. All right, so back into our code editor, right? So we really messed this up. So I'm going to just come here and I'm going to say let's call this using snapshots. All right, so once again I'm going to create another array. Let's mute array. Let's call this array 3 since we have a lot of arrays already. All right, and as always, just use this short form 1 2 3 4. All right, so we have this array with 4 items. Now we're going to take a snap of this array before we do any further modification to it. So I'm just going to say let snap 1 be equal to @array3. Now this you can see here is basically how you signal to Morse code. That's just basically how you signal to your compiler that you want this to be a snapshot. This is how you present snapshots or create snapshots, basically using this @symbol. All right, now we just created a snap of our array, right? Now we're going to carry out the modification. So I'm going to say array3 dots let's append a new value. I'm going to append a new value to array3. So I'm going to, let's say, append 5. All right, so now we could assume that the length of array3 has increased, right? But like I said, a snapshot takes a picture of it and does not reflect any further modification you make. So we want to assume that the length of this particular snapshot should still remain 4. All right, let's check it out. So I'm going to just print those values out. let's see, length of snap. So I'm going to say the length of snap should be essentially snap one dot len. Alright, then I'm going to print. I'm just going to copy this, duplicate it. Okay, and the length of array 3, and this is going to be array 3 dot length. Okay, all right, so let's just close this and clear and run scap Cairo. All right, so as you can see, it says the length of the snap is 4. So even though we called this length after like we carried out this append, what's it called, this append operation, right? You can see every other modification you make after creating the snapshots, it no longer matters. So the snapshot just retains the particular picture of the variable it took before any other modification happened. So that's why, as you can see, snap 1 retains the original length, which is 4, but the length of array 3 actually retains the modification or reflects the modification, thus showing as 5. Now that's basically how you use snapshots. Now snapshots, while using snapshots, something else you need to take note of, right, is the desnap operator. So most times, okay, for example, let's assume that this our main function return like a unit value, right? Now if you try to return what's it called, let's say an item or a value from this snap variable, right? So let's say the snapshot. So let's say I was trying to return the second item. So you can see we have an error. Now if you try to let's try to build this, right? Let's see the error it shows. So you can see it says there's a type mismatch. So we're trying to return the return function is expecting like a uint8, right? But it's getting a snapshot. Now this is where the snap operator comes in. So using the snap operator to convert back to a normal variable from a snapshot, and to desnap, like we call it the process desnapping, right? And to desnap a snapshot, you just simply need to add this asterisk sign. So when you add that, you automatically have desnap this operator. So if we basically like clear this and try to build again, you see like we no longer run into errors, right? Because this is now a proper uint8 variable. All right, so now I'm going to let's try something else. So let's assume we had another function, right? And okay, in this case, for example, the append value function, but I'm going to create another one. So let's call this pop array instead, so we can do something else. Now this is going to take in this is going to take in all right, let's make this take in a snapshot just to understand something first, just to prove a point. So we're going to make this take in a snapshot, right, of the array. Okay, and we want to take in array 3 and probably perform the pop front operation on it. That's remove the item like in front of the array. So I'm going to say just to have something to store it. So let x be equal to array dot pop front. Okay, so now you can see we have an issue. If you hover over this, it says ref argument must be a mutable variable. So essentially, snapshots cannot be mutated. Like I said, it's just like a picture of the variable you took at some certain point in time, right? So if you want to be able to, but if we let's say wanted to just return the value, we don't actually have a return value, but let's say we could return something here, right? And you were just trying to return the value alone, like you shouldn't have any issues with returning it. Just throwing an error, expected parameter. Well, so you basically shouldn't have like an what's it called, an issue returning it, right? But we are actually having, oh sorry, this is actually supposed to be in here. I was saying nonsense errors. So this unexpected return type, yeah. So if you're going to return this, as always, you have to kind of like this snap it. So this still throws an error. Oh, cannot snap in non-copyable type. So let's just assume we're trying to return one item per minute. and it was going to be unit 8. All right, so that works now. All right, so I don't just forgive that mistake. So essentially your snapshot should be in front of like your data type. All right, so now as I was saying, right, if you are trying to just return it, we should have no issues, right? But if you're trying to perform an operation on it, in this case, what we're trying to like remove the first element in it, right? If you're trying to do this now, you're going to have like an issue because you can't call this on like on a snapshot. A snapshot is not supposed to be mutable. So in that case, what do you want to do? So what you're going to do instead is, instead of passing in a snapshot, you're going to pass in what we call a mutable reference. Now, a mutable reference is different, way different from snapshots. It behaves differently, right? And basically all it does is they are basically mutable values that you pass to a function that's automatically returned at the end of the function. So now if we pass in this array as a mutable reference, right? Once we are done with like performing whatever operation we want to perform on this particular array, right, it's going to automatically return so just close this so make the error disappear. All right, so let's just see that x equal to, so this is smaller, prevent that. All right, so as I was explaining, right, when you pass in as a reference, so all it does is this array performs like whatever operation is going to perform on it, and it automatically returns, or it implicitly basically returns that array or whatever it is that you passed, that variable you passed in as a reference, back to like whatever function that calls it. So in this case now, if we had, let's say we had a function in here and equal to that pop array, so let's call pop array and we try to pass in array 3, having an error 0. Oh, sorry. So when you're passing in ref, you need to like precede it with the ref argument. So essentially, some things you need to take note of, right, when you're trying to use mutable references. The value you're passing in has to be a mutable value. For example, array 3 has to be something that couldn't be mutated, because if it's not, you're going to get an error here that says ref argument must be a mutable variable, right? So it has to be an argument that can be mutated. That's one. The second thing also which I mentioned earlier is that when you pass in a value as a reference, right, automatically it gets returned. So the ownership of array 3 gets returned back to this pop array, and you can essentially still use it like down below even after like the pop array. And that's just basically how snapshots and mutable references work. So in summary, snapshots are basically used to like get a picture of like a variable, right, at a particular point in time, and does not reflect any further modification to that particular variable you took a snapshot of. But mutable references, when you pass, are basically used for cases where you want to mutate the value you're passing in, but you still want to retain the ownership. So it takes in that mutable value, it performs whatever mutation you need to perform on it, and it implicitly returns back that that variable, that argument, that array, or whatever it is. And yeah, that's just different between both. All right, so let's just go back into our code editor. Sorry, our Cairo book, to see if like there's any other thing we're missing. Okay, so we already looked at snapshots. We just used a different example. All right, so the Desnap operator, we already looked at that. We already touched on mutable references. Alright, so that's as much as it is. So the recap, right, at any given time, some things you need to take note of, right? At any given time, a variable can only have one owner. So you can pass a variable by value, by snapshot, or by reference. So those are the three ways you can pass like a variable: by value, by snapshot, or by reference. So if you pass by value, the ownership of the variable is transferred to the function. So if you want to keep ownership of the variable, know that your function won't mutate it, then you can pass it in as a snapshot. But if you want to mutate it and still keep ownership, then you have to pass it in as a reference. Alright, so I guess that we did justice to like understanding ownership. If you have any questions, you can always reach out to me on Telegram on Darlington68, or on Twitter at Zerex Talented. So let's just take our quiz before we kind of like call it a day. Okay, so the first question says determine whether the program will pass the compiler. If it passes, write the expected output of the program. Alright. So I already know this is not going to pass even without even looking at the main function, and that's because this is a Desnap operator being used on a reference to immutable variable. So you can only use a Desnap operator on a snapshot. So automatically I know this is not going to compile. So the next question says determine whether the program will pass the compiler. If it passes, write the expected output of the program. Alright, so we have our struct, okay. Then this struct, so we have this function double rect, which is passed, the reference is being passed in, okay. Then this is our main function, so we have this rectangle in which is instantiated, and a reference to the double rect is passed in, and this is printed out, okay. Let's see, double rect then 20. This will not compile. Okay. Then the question 3, determine whether the program will pass the compiler. If it passes, write the expected output of the program. Alright, so this is a sum function that takes in a snapshot of an array, loops through it, desnaps it, and adds it to this sum. Okay, that's the main function. So the main function instantiates an array. We take in a snapshot of the array. We pass that snapshot into a new variable. We append a new method to this initial array. Then this new snapshot of this is passed into snap2, which was mutable. Then we are trying to call the sum function passing in snap. So snap takes in a snapshot of array1. So this is what's going to get passed in. So this code looks correct, which means the code should compile. So but what's going to be our responses? So it's going to basically be, since this we're passing in the snapshots which took note of this here, that's the only thing we're going to focus on. We're not going to look into any other modifications. So this is going to be 1 plus 2, which is 3, 3 plus 3 is 6. So this compiles, program output to be 6. Alright, so the next question, so choose the working code snippet that properly defines and uses the function to insert a value at the end of an array while removing the first element and returning it. The array has to be modified by the function and should be usable after the function call. Okay, so this is the first one. Start with main function. An array is instantiated, give and take. Okay, this is passed in as a snapshot, and we're trying to append, so automatically we know this is not going to work. You can't like mutate snapshots. When you pass a value by snapshots, you can't really mutate it. So this is not going to pass. I clicked that, but that's not going to pass. Then this function give and take, what does this do? So we instantiate the array, we pass it in as a reference with this. Okay, take a reference to it, array.append and array.popfront. Okay, I don't think this is going to pass. So let me see this other one. So function give and take, this is passed in as a snapshot. We can't really append, so no. So this is not passed in as a reference but expects a reference, so no. This function give and take reference to array. Okay, so we have this array, calls give and take, passes it in as a reference at the item. Okay, array.append n before, then takes it back off. Okay, and should return it back. So I think this should be the correct answer. Let me just compare it against this again to be sure. Yup. Yeah. So this is a mutable reference. Oh, right. Yeah, so it's this one. But while both of them are similar, I just noticed something. Remember, we mentioned that immutable, when you're passing as a reference, the value you're trying to pass in has to be a mutable variable. So this is not a mutable variable, and we're trying to pass in. We're trying to pass it in as a reference. So this is not going to compile, but this compiles because this is a mutable value and we're passing it in as a reference, takes it as a reference and performs this operation. So yeah, this should be our final answer. Alright, so let's see if we passed that. Okay, so we answered all questions correctly. This is correct, this is correct, this is correct, and this is correct. All right, so I hope you tried it out on your end and you got them correctly. If you didn't, then take out the time to read the context or check out the context. And with that, we've come to like the end of this particular episode. If, like I said, if you have any questions, feel free to reach out to me. I'll be happy to like answer your questions. And yeah, of course, if you have any feedbacks, drop them in the comments or reach out to me personally. Also, I would appreciate your feedbacks. And of course, as always, if you learned something new or you liked this particular episode, to like, subscribe, hit the notification bell so you are informed every time we drop a new video, and you do well to share with other persons who are looking to like learn the Cairo programming language. Thank you and see you in the next episode.